So this one here has, they often give you hydrogen ion concentration. They called this hydronium, so I left it be, but I guess it's wrong, so whatevs. All you chemistry people. But you have your acidic, you have your alkaline, you have your neutral. We don't really care about that in mathematics. The world does. But we either just have to, they're either going to give us the pH and make us to solve for the hydrogen ion concentration, or they're going to give us the hydrogen ion concentration and solve for the pH. So it's nothing that's like hardcore. There's way more pH formulas out there in the world. I kind of stick with this bad boy for our test. So here it says, tomato juice has a hydronium ion concentration of approximately that. So we either have pH or H+. So it's H+. They gave us 0.0001 moles per liter. I remember absolutely nothing from high school chemistry, just so you know, like it left me a long time ago. They want the pH. Literally, when we're given anything, it's only because it has the word log in it. That's where you're going to get. So they can give you any log. Yeah. Yeah. Where are the extras? Give them back to me. This one. So basically, they can pick any log equation, any log formula in the world and give it to you on your test, correct? That's what they have to do. All you're doing is you're plugging in all the knowns, minusing one unknown, and solve for it by usually converting to exponential. That's ultimately the goal in all log word problems in all of math, right? For us, because our goal is not to solve a log word problem like a specific pH word problem, it's to solve log word problems. So you get a log equation, you fill in all your knowns, miss one unknown, usually convert to exponential, poof, have an answer. So can I convert, oh, I got to fill in first. So I have pH, this one's even easier, I don't have to convert it, minus log 0.0001 moles per liter. And I really hope they give us this, because there's actually nothing but typing it into your calculator. And so you get 4. I doubt that's happening. I'm going to guess that if they give you one, they're going to be missing something else in it, like the H+, so you actually have to convert, right? Oh, wait, here's one. Okay, blood has a hydronium ion concentration of approximately 4 times 10 to the negative 7 moles per liter. So that's our H+. No, I lied. We're still in the easy part. And they want to know if blood is acidic or alkaline. Where's the cutoff on alkaline and acidity? 7. Okay, good, I have you. They will never ask if it's alkaline or acidic. I thought I'd throw that in there because I thought it brought great joy to people everywhere, just not me. So, you know, it's all not always about me. So I left this be here, and then I always make people answer me every single year and tell me what it is. So I get log 4 times 10 to the negative 7 moles per liter. And when you type that in, which you only need the log button, you get 6.4. Is it acidic or alkaline? Acidic? You guys aren't making me believe you.
Acidic.
There we go. That sounds more.
Thank you.
So at 7 and higher, it's alkaline? Is that how she works? What is 7?
Neutral.
Neutral. Every single semester, I do this. What is 7? What's greater? What's less? Every year. I just make you guys answer. I only put that in there for joy of others, not for myself. All right. They will not ask you if it's acidic or alkaline. It doesn't matter if you've been in chemistry before. I promise you. They will ask you for something where you literally just have to solve for variables, right? Because that's the math part of it. So orange juice has a pH of approximately 3. What is the concentration of hydronium ions in orange juice? So we have 3 equals negative log H+. And what did I tell you to do whenever a log doesn't have a base?
10.
Make a base of 10, because that will often help you out. This one is always tricky, gets people. Can I convert in the way that it is currently?
No.
No, why?
Because there's a negative in front of the log.
You're right. There's a negative in front of the log. So we're going to divide the negative 1 over. And then we have negative 3 equals log base 10 of h plus. Most people won't spot the negative 1 as a problem. If it's a 2 or a 3, they know they need to divide it over. But the negative 1, they kind of just ignore it. They're like, I don't really care about it, and then ignore it. So now that we have log by itself, we have the base of the log times the base of our exponent. So it's 10 to the negative 3 equals h plus. If I do some of this, I'm going to fall. H plus equals 0, decimal 0, 0. Okay, so that's your pH. Like I said, they can give you any log equation though. They can find any log equation in chemistry or wherever and give it to you. Okay? Ultimately, you're usually missing the thing that's beside the log, so that you just convert to exponential and get it. Okay? So then we have decibels. So some common sound levels are indicated in the decibel scale shown. The difference in sound levels and decibels can be using this formula. Where B2 and B1 are not decibels, they're actually bells, not decibels. So what the heck does that mean? Well, in your little stepping scale, you had like decimeters and meters, right? You would have deciliters and liters, correct? Okay. This is just decibels and bells. So these are all in decibels. What would they be in bells?
Times 1. Times -1.
The negative 1. Yes, interesting way of saying that. I say move the decimal 1 to the left. Personally, that's how I go. Because you're just staircasing, right? You're going like this. Here's your decimal. You're moving it 1 to the left. So all of these, if I wanted them in bells, this would be 20.0. This would be 16.0. This would be 15.0. This would be 12.0, 10.0, 9.0, 8.5, 8.0, 6.0, 3.0, 1.0. That would be bells. Now, they often give you a convoluted equation like this. I never use that. I will use the same format for every single, whether it's a decibel question or a magnitude question. What I always do is because this intensity ratio is it's just an I. They don't give you two intensities and make you find a different bell. So I always just say, thank you for that. And then I say, no, thank you. And I use I equals 10 to the B1 minus B2. And how I use the formula is if my intensity is large. So if my intensity is greater than 1, the V1 is the larger, I guess this would be louder sound. And if my intensity is between 0 and 1, which means it's actually decreasing, right? My V1 would be the quieter sound. Log formulas they often give are a little bit confusing as to how you fill them in. But basically, if your intensity is large and growing, your B1 is the louder sound. If your intensity is decaying, your B1 is the smaller sound. Because you'd have to have the smaller sound here in order for it to decay. Or the larger sound here. Then I'm going to flip over. Yeah.
What's I?
Intensity.
Okay.
So I2 over I1 is the intensity. They could just label it an I. Because, the way that we do it, we never give, like, the intensity of one is the intensity of the other and then ratio it out ever. We don't do that.
The intensity of what?
The sound.
Aren't there two sounds?
Sound intensities. Well, there's the rate at which it's growing or decaying. That's what it is. So here, I'll show you. We'll go to an example to make sense. So the way they ask the example is like this. How many times as intense? So it's a ratio of intensity.
Okay.
Do you know what I mean? Like they don't ask for the intensity of one or the intensity of the other. They're asking for a ratio of the intensity. So it's how many times as intense or how many times more intense or how many times less intense. So it'll be then this one, then this one. So it's the intensity differential between the two.
Okay.
So here it says how many times as intense as a whisper is the sound of a normal conversation. So how many times as intense? So they're looking for the larger intensity. How many times as intense as a whisper is the sound of a normal conversation? So we're looking for a larger intensity. How much times more intense, basically, is the normal conversation than the whisper? So the formula I need is I equals 10 to the bells 1 minus bells 2. And I want, which one's louder, a normal conversation or a whisper? I really hope you know. The normal conversation. So how many times as intense as a whisper is normal conversation? So they want to know the intensity, how much more intense is a normal conversation than a whisper. So they want a big intensity, right? A bigger intensity. So I'm going to put my conversation first and my whisper second. Go on the front of your page, what is the bells of a whisper, or of a conversation, sorry. 6.0. And then what is it for a whisper? So it's 10 to the 3, which is 1,000. So it's 1,000 times as intense. So a normal conversation is 1,000 times as intense as a whisper. Now B talks about the sound level in a normal city traffic is approximately 8.85 decibels, but I need 8.5 decibels. The sound level while riding a snowmobile is about 32 times as intense. So actually a snowmobile, is it louder or quieter? Louder than normal city. Have you ever been on a snowmobile? They are loud. So it's 32 times as intense. So I know my I is 32. We agree? That means it's growing. It's going faster, right? Growing. So if it's growing, my first number of B1 has to be what? Bigger. So that's the one I'm trying to find. And my B2 is 8.5 bells. So I know that my answer needs to be greater than 85, right? If my answer is less than 85, I put them in the wrong spot. Like, you should be able to reason yourself out of it. So if you put 8.5 as B1, you're going to actually get a smaller number than 85, and then you'll know, oh, I messed up, because the snowmobile needs to be louder, right? So 32 equals 10 to the B1 minus 8.5. Now, some people might say, well, how is this in the log word problem? What must I do? Convert to a log, right? They just gave you the weird log equation at the beginning, but I always use this one. So now I have log base 10, which I don't have to write the base, but I am, to prove a point, of 32 equals B1 minus 8.5. And then I just have to add my 8.5. So I get log base 10 of 32 equals B1, oops, plus 8.5 equals B1. And so then B1 equals 10.0 bells. But what do they want it in? Decibels, because it says in decibels. So we move our decimal place 1 to the right then, to undo what we did. It's 100 decibels. Then we would write a sentence. What is the sound level when riding a snowmobile? The sound level moving on. All right. Earthquake magnitude. They usually give you this weird formula. I'm actually not sure how you're supposed to fill your stuff in. It doesn't even give you M1 and M2, but they'll give this to you. And they'll say M is the difference. The magnitude M of an earthquake is measured in Richter scale, which is this, where I is the intensity of the earthquake being measured, and IO is the intensity of the standard lower level earthquake. But then they give you two magnitudes, and I don't even know like what. So I just use the same formula as that one. That's why I stick with that. So I go intensity equals 10 to the M1 minus M2. Following same rules. If the intensity is greater than 1, the larger earthquake magnitude comes first. If the intensity is less than 1, the smaller earthquake magnitude comes first. I don't think they use the Richter scale anymore, do they? They use a different. Is it the Richter? There's one that's even better, but it's not the base 10, so they actually find it harder. So some people don't realize, like, a magnitude 5 earthquake and a magnitude 6 earthquake are substantially different. They're like, oh, that's not too bad. They're 10 times as intense. Whenever you jump 1 on the magnitude scale, it's 10 times as intense. So if you go from a magnitude 5 to a magnitude 7, it's 100 times more intense than the magnitude 5, right? Because it's a base 10 scale. So there's a better scale. They do use this for earthquakes with magnitude still, but there is a better scale. Because this one's just not as accurate or something. They were talking about. I've looked it up before, and I forgot. We'll look it up later. So they always give magnitude base 10 questions on the diploma. Every, I don't know, 1 out of 2 or 1 out of 3 tests, the magnitude question comes up, or a PH question comes up, one of these. So here it says, how many times as intense as a standard earthquake is the earthquake measuring 2.4 on the Richter scale? Oopsies. So did they give us the bigger or the smaller? So this one, they gave us barely any. So we could actually use the formula above. This is the only way I want to prove. This is the only way this formula is helpful. Because it literally is just asking you for the magnitude. How many times as intense is the magnitude of that? So you can go 2.4 in for your magnitude equals log. Which one are we going to have? Do we have I or IO? If you're stuck, if you don't know, they're asking us for the intensity. So that's why it's just an I. It's a ratio. Remember when it says as intense, they don't actually give you I or IO, they give you a ratio of the two. So they give you this. They give you this whole ratio when they say as intense. So it'd be I equals 10 to the 2.4. Which I'm guessing is 251 because I put all the answers in brackets. Woo, we have the answer. So this is the only way I could see that formula working. Okay? They don't often ask it like that, but I wanted to give it to you because I've seen the formula and I was trying to figure out how could I use this formula. That's about it. Let's look at this though. This is more so what they give you. They give you one magnitude and they give you the intensity and they ask you for the other magnitude. Just like they give you one bells, they give you the intensity, they ask you for the other bells. Right? That's more so the way they say. So it's more like this. A major earthquake of magnitude 7.5 is 375 times as intense as a minor one. So find the magnitude to the nearest tenth of the minor earthquake. Now, keeping in mind, magnitude of earthquakes are base 10, correct? So if I'm at 7.5, 6.5 would be 100 times less, or 10 times less. 5.5, like we just go down on our base scales. So here we go with, my brain forgot what I was doing. 10 to the M1 minus M2. My intensity is what? 375. Is that big or small? I hope you know that's big. So the big earthquake comes first. This is the hardest part. Did they give us the big earthquake magnitude or did they give us the small earthquake magnitude? A major earthquake of magnitude 7.5 is 375 times as intense as a minor one. So they gave us the big one. So that comes first. Minus M2. How do we solve this? log base 10
Log base 10.
of 375.
Log both sides.
You could log both sides. It's more work, but you could do it.
Nathan says that's what you're doing.
I converted.
That's what.
It's not really. Of course, we leave Nathan over here to attack me. You're fully attacking me, Nathan.
Yeah, I really have so much bearing on this.
If Vaughn agrees, it's true.
Yeah.
What is your opinion?
I don't know. Is it the same or not?
He's saying that if you log base 10 both sides, the 10 and the 10 will just cancel off and you'll be left with that. So technically that's what we're doing when we're converting. It's not wrong, but he's doing math in his head that other people aren't going to do. And so therefore, I'm just going to confuse everyone. So I'm not going to say it that way, Nathan.
Okay.
Because if you log base 10 this side, it's 10 to the 10 to the 7.5 minus m2. And so the 10 to the 10 cancels and I'm left with just that. That's why he's saying because you log base 10 both sides. M2.
I think you're wrong.
He's not wrong. It's just longer because he's converting that in his head, but most people can't do that. So you're adding an extra 2 steps. Some people's children. Talk to Nathan's mother tomorrow. Gonna have a talk about him overachieving and having to reduce his overachieving level, maybe. You know? Maybe reduce it. Maybe achieve a little less. Never had to do that before, but today's the day. I mean, actually, tomorrow's the day. All right. Okay. So, actually, in your hand-in now, that hand-in I did, there's a magnitude question in there, there's a log question there, I think there's a pH question in there, there's one of each type. Go through and try those. That's your homework. The textbook has really bad ones.
Wow.
Like, not even slightly bad.
Wow. Aren't you getting ready?
Pardon?
There are.